Okay, so now let's try to connect the dots. So let's try to connect the dots between A, D, and B. We know A is our starting material, D is our intermediate molecule that we could potentially isolate. All of the bonds have been made and broken, and B is our final product. So if we were to try to connect A to D to B, one common mistake is to try to connect like this, where D is a local maximum. Now you have to remember this isn't the way it's going to work because the local maximum or local maxima are going to be indicative of transition states. And transition states are these moments in time where bonds haven't really been formed and they really haven't been broken. And we don't really include the transition states in the mechanism, so they're kind of happening in this middle part where we're not really showing. So you have to remember that we have to have a transition state between A and D, and the transition state is going to be the local maximum. So this is the way it would look, A to D. We're going to have our local maximum, this is our transition state, and then we're going to form all of our bonds and break all of our bonds to get here. And then to get from D to B, we know that B is our final product, D is our intermediate. We have to have this kind of energy maximum as well, again, going from D to B. So let's see if I can draw it. So this is our local maximum, and we're going to go all the way down to B. Okay, and then we would just do a very similar thing going from A to E to C. So I'll just use a different color for this and go from A to E, again going through a local maximum transition state. This is our intermediate, and then we're going to get all the way back down to our final product. So notice again, we have two local maxima here and here. Okay, so now let's remind ourselves of the overall question we were asking at the very beginning, which is, of the two products, or the two possible products, B and C, which is going to be a major product and which one's going to be a minor product? And we're going to use this energy diagram to help us answer this question. So what I'm going to do is just going to give us a baseline. So A is our starting material, and what we're going to do is we're going to use this analogy of trying to ride your bicycle over a hill. So if A is our starting position, so A is the product or starting material for both potential products, B and C, you could imagine yourself riding a hill up this blue hill as well as up the yellow hill. And so that equates to the amount of energy that you have to put into the reaction to get these two intermediates, D and E. So to get to intermediate E, you have to put in about this much energy, the difference between A and E. And to get to D, you have to put in a different amount of energy, the difference between A and this hump to get to D. Okay, so if you look at the energy difference, it looks like you have to actually put in a lot more energy to get to this intermediate D. And the analogy is you would have to ride a lot harder, up a much harder, more steep hill to get to this position. And so obviously if you had to choose, you're going to choose to be lazy and you're going to choose to go up the hill that's going to require the least amount of effort on your part. The molecule is no different. So it's going to try to go up the hill that's less difficult to go up. And in reality what's happening is the molecule is trying to sample both hills, and it just turns out that because this hill to get to intermediate E is much easier to get over, we're going to actually form more of E versus D. So because it actually turns out we need less energy to get to E, it's going to be easier to get to this position. And because it's easier to get to this position, it's going to be easier to get to product C versus product D. So at the end of the day, the major product is actually going to be C. So this is going to be our major product right here. And B is going to be our minor product. All because of this energy that we have to put in to get to the first intermediate versus the energy that we have to put in to get to the second intermediate.